This video is a continuation of your Unit 2B review. On this video, we're going to cover numbers 8 through 12. So let's start with number 8 that asks us to solve the following equations using the elimination method. Okay, on the test, there'll be a problem like this, a question like this, and you will have to show your work using the elimination method to get full credit. All right, so the elimination works because what we want to do is eliminate either the x or the y. And you do that by either adding the two equations together or subtracting the two equations. Now, these equations as written, if we either added or subtracted them, neither the x nor the y would be eliminated. So I think I'm going to do what I suspect most of you would want to do, and that would be to add the two equations together. And I noticed that looking at the y terms, this is a negative 2y and this is a positive 6y. If this were just, instead of negative 2y, if it were negative 6y, then when I add the two equations, the y terms would drop out. So we can make that happen if, to make this become a negative 6, if we multiply both sides of the equation by 3. Now make sure whatever you do to one side of an equation, you do the same thing to the other side. Both sides of the equations need to be multiplied by 3. So now let's write our new system. The first equation will now be, after I distribute this 3 on the left side, we'll have 15x minus 6y equals, on the right, negative 16 times 3 would be negative 48. And then I'm going to rewrite the second equation as is, not going to make any changes to that. And now what we're going to do is add the two equations so that my y terms will be eliminated. 15x plus another x would be 16x. Okay, the y, negative 6y plus positive 6y eliminates that y variable. And then on the right, negative 42 plus 16 would be negative 32. All right, and then let's divide both sides by 16 to get our x value, and x is equal to negative 2. All right, so that is half of our solution, okay? To get our y value, we can go back to either equation, doesn't matter which one, and where I see an x, I'm going to replace it with negative 2. So I think I'll use the second equation. That seems to be the simpler choice. So instead of x plus 6y equals 16, we're going to write negative 2 plus 6y equals 16. And now let's solve this equation for y. We'll start by adding 2 to both sides. And we'll get 6y is equal to 18. Let's divide both sides by 6, and y then will be equal to 3. All right, so we have found our x value and our y value. Let's write our answer as an ordered pair, negative 2, comma 3, and there is our solution. That would be graphically the coordinates of the point where these two lines intersect. Algebraically, negative 2, 3 would be the x, y values that work in both equations at the same time. All right, moving on to number 9. We're going to solve these equations using the substitution method. All right, substitution method, again, there'll be one question like this on the test, and you will have to show work using the substitution method. Okay, what the substitution method works by taking either equation, it doesn't matter which one, and solving it for either x or y. Again, it doesn't matter which variable, so choose what you think would be the simplest. It looks to me like this first equation could be solved for y very simply just by, let's see if I can squeeze this in here, subtracting, let's see, 2x from both sides. Oh, I can't read that, hold on. Let me fix that. We're going to subtract 2x from both sides. I think I'll do the work over here so you can see it a little bit better. So rewriting the first equation, 2x plus y is equal to 7. I'm going to solve that for y by subtracting 2x from both sides. Okay, and we will get that y is equal to negative 2x plus 7. Okay, now I solved the first equation for y. So now what I'm going to do is go to the second equation. Where I see a y, I'm going to replace that y with this expression, negative 2x plus 7. Over here, we're told that y and negative 2x plus 7 are the same thing, so I can replace one for the other. Okay, not a lot of workspace on this problem, so I'm going to bring my work over here. And I'm going to just rewrite that bottom equation. 3x minus 4 times, now instead of y, remember I'm replacing y with negative 2x plus 7. So start some parentheses, write negative 2x plus 7, close those parentheses, and then let's finish the equation. That's equal to negative 17, equals negative 17. All right, simplifying on the left side, we need to get rid of these parentheses. So start from the left, rewrite 3x. Let's take negative 4 times negative 2x. Now that will be a negative times a negative, so plus 8x. And then when I take negative 4 times positive 7, a negative times a positive is a negative, so I should write minus 28 is equal to negative 17. Let's take one more step to simplify the left side by combining these like terms, and we'd have 11x minus 28 equals negative 17. Whoops, what did I just do? Sorry about that. I don't know what just happened. Okay. All right, there we go. Sorry about that blip. That's equal to negative 17. All right, now let's add 28 to both sides. Adding 28, and we get 11x is equal to negative 17 plus positive 28 will give us a positive 11. Now I've run out of workspace here, but I think you know what to do. Divide both sides by 11. X is equal to 1. All right, so now we have our x value. Okay, that's half of our solution. To get the y value, I can go back to either of these original equations where I see an x, replace it with 1. Or it might be simpler, as long as I haven't made an error writing this equation, this might be the easiest place to find out what y is. So I'm going to replace this x with 1. Y is equal to negative 2 times 1 plus 7. And then doing the arithmetic, negative 2 times 1 is negative 2. Negative 2 plus 7 equals 5. And so let me squeeze this in here. Y is equal to 5. All right, let's write our answer as an ordered pair. Over here, put our x value first and then our y value. So our solution would be the 0.15. All right, moving on to number 10. It says, write the system of linear equations represented by the matrix equation below. Okay, now in this matrix equation, remember the first matrix is what we call our coefficient matrix. The second matrix is our variable matrix, and the matrix on the right side of the equal sign is your constant matrix. So, since these are coefficients of your first equation, our first equation would be 1x, or just x, minus 1y, or just y, is equal to the constant negative 2. And then our second equation would be negative 2x plus 5y is equal to 8. All right, now we're done at that point. The directions just said to write the system of linear equations. We don't need to solve it. All we need to do is write the system. So at that point, we're done. Sorry about my sloppy writing. This is a y. Just want to make sure you're all sure that this is an x and that's a y. Okay, number 11 says, how can you write the following matrix equation using the inverse of the coefficient matrix to find the solution? Remember, the solution would be our value for x and our value for y. So let's take this matrix equation and rewrite it. Our variable matrix is xy, okay, and we're going to find those solutions by taking the inverse of the coefficient matrix. So we would write that like this. Just rewrite the coefficient matrix, 1, 5, and negative 2, negative 4, okay? And if I want to indicate the inverse of that coefficient matrix, we raise it to the negative first power, and then we multiply that by the constant matrix, 7, 10. All right, now at that point we're done. How can you write the following matrix equation using the inverse of the coefficient matrix to find the solution? That's exactly how we would write it. You don't need to solve it. All you need to do is rewrite that equation. All right, and then number 12 says, complete the matrix equation and solve. So this big matrix is going to be our coefficient matrix A. We're going to multiply that by the variable matrix and set it equal to the constant matrix. Okay, Now, let's take a look at the first equation. It looks like it's in standard form. I see an x term, a y term, a z term in that order on the left, constant term on the right. So I'm going to take these three coefficients and write them in the first row. So that would be 3, -2, make sure you look for the sign in front of the term, and then +1. Okay, now the middle row in our coefficient matrix, okay, notice I have an x term but no y term, and then a z term is equal to my constant. So I know the first number in the second row is going to be 4 because that's my x coefficient. When I don't have a y term, there has to be something here in this spot in the coefficient matrix. So let's just go ahead and add a 0y term to this equation. So I'm going to put 0 in for my y coefficient and then 2 in for the z coefficient. And then the bottom equation looks fine, an x term, a y term, a z term on the left in that order, and a constant on the right. So the bottom row of coefficients would be +2, -3, and -5. Again, make sure you look at the sign in front of the term. That's part of the term, so don't lose those negative signs. Okay, this is our variable coefficients. Our variable matrix. Our variables are x, y, and z. So this will be a 3x1 matrix, x, and then y, and then z. And then over here is our constant matrix, another 3x1 matrix. It would be 5, 6, and -12. 5, 6, and -12. All right, now, to get your solution, okay, follow the steps you've learned in class, or you can find the instructions in your notes, or if you look back at that 2.7 video, it describes how to solve, how to do the calculator work to solve an equation or a system of equations using matrices. 2.7, those were 2x2 matrices. So this would be very similar. So go back and look at that, or ask a friend or ask me. Get help if you're not sure what to do here. To get your solutions, you're going to take the inverse of the coefficient matrix, multiply it by the constant matrix, and when you're done, you should get 0 for x, -1 for y, and 3 for z. All right, I'm going to stop this video and continue the rest of the review on another video.